This is our third section in 1315 surveying calculations in our first week, and this is a lesson on volume. So I guess I should be talking a little bit louder. In any event, surveyors have an advantage. We have the ability to measure more accurately with better tools than most people have, and we have a certain amount of training and calculation, and that's what you're learning how to do. And when you work, say, with oil field or water service companies, they've got a lot of tanks that sometimes need to be measured. And if someone has built a tank farm, they would like to know that if it was indeed built to the specifications. And who do they hire to find out if that tank is indeed 50 feet across? They hire a surveyor. So in any event, we measure lengths and we calculate volume and area. So anyway, the unit of measurements for volume for solids in the U.S., and that's dirt and grain and things like that, is going to be cubic feet and cubic yards. Grain gets calculated in bushels, but we don't have to worry about that. We're doing more the engineering rather than the marketing side. So anyway, cubic feet and cubic yards, there are 27 cubic feet in 1 cubic yard. And that's a figure you just need to know, because it's 27, because it's 3 feet by 3 feet by 3 feet. That's 3 cubed is 27. Units for volume of liquids in the U.S. are generally gallons and barrels are going to vary by the material being measured. And once again, talk about, the unit of measurement should be appropriate to the thing being measured. And if it's oil, it's 42 gallons per barrel. And there are other things that are measured in hogsheads, like tobacco. But we're not going to worry about that. Now, I put in the volume of a cylinder because every once in a while you get called upon to measure in something like a spherical tank. There aren't that many of them, but they do exist, and nothing to get excited about. It's a very simple formula. Pi times the radius squared. The volume is equal to 4 over 3 times pi times the radius. And it's not a formula that you use very often. So the volume is equal to 4 over 3 times pi times the radius. Now, one thing that there will be a lot of exercises in surveying, and that's going to be figuring the volume of material to be either removed or to fill in, and that's the trapezoidal ditch, flat bottom ditch. So how do you figure it? You get the height. You get the average of these two. So it's the height times the average of these two. And we'll say that this is, what did I say? And that's going to be 5 feet high, 8 feet, and 12 feet. So the average of 8 and 12 is 10, times 5 is 50. And if it's 100 feet long, you have 5,000, 5 times 10, okay, so 5,000 foot squared, foot cubic. That's your figure. I've got my calculator. So 5,000 divided by 27 is 185 cubic yards. So if each dump truck holds 5 yards, you simply divide 185 by 5. That's all there is to it. So you will be called upon to measure the volume of a lot of things in your career as a surveyor. So get used to it. I've got this example here. There really isn't all that much to it, because all it is to calculate volume is, unless you get into something prismatically shaped or a cone or something like that, we're not going to work with that too much, not at this early stage. But all it is cross-section area times length. So if this is 50 and that's 100, it's 5,000 of whatever unit of measurement. And then if your unit of measurement is different from your unit of volume, that is to say, you measure the square or the cubic area, or excuse me, the cubic volume, but your unit of measurement is cubic yards, you simply divide by 27. It's not rocket science, it's not complicated. Don't try and make it complicated. A cylindrical tank 8 feet across and 12 feet high contains how much liquid? One of the things you're probably going to get tired of me saying, and sometimes I get tired of it myself, but it really works when you do it, is to solve a problem, draw it. So anyway, you have a cylindrical tank, 8 feet across. 8 feet is 4 and 4. The radius is 4. So how much volume does it have? 4 squared, radius squared, times pi, times 10 feet, let's see, 12 feet. So that's 16 times pi. I misplaced pi. There it is. Times 12 equals 603 cubic feet. And how many gallons is that? I didn't talk to you about gallons yet. There are 7. So let's just say that this is 603. One of the nice things about this calculator is that you can store that number, and if you've got a lot of calculations to do, or if you need a particularly exact number, just store it and then bring it back in when you recall it when you do the actual calculating, because that way you don't have to write out such a large number. But anyway, what a gallon is just an old unit of measurement, and 1 gallon, excuse me, 1 cubic foot equals 7.481 gallons. That's a lot of gallons in 1 cubic foot, but you almost never see a cubic container that's 1 foot on a side. So 7.481 gallons per cubic foot. So you have 603 cubic feet, and let's see, 16 times pi times 12 equals 603. Okay, I got that right. Now, do you divide or multiply? Well, you have that many cubic feet, so you multiply by 7.481, and you get 4,512 and change. So that's about right. 8 foot across, 12 feet high, gives you 4,500 gallons and change. Like I said, this is not complicated. Don't make it complicated. The same formula works with pipelines. If you've got a pipeline that's 1 foot across, then all you have to do, your radius is then 0.5 squared times pi times the length of the pipe. So lots of different calculations from the same formulas. So that's it on this lesson, and we're going to keep going.